Bunch. All right. This is not a hard trick. This is actually pretty early on the test usually, second column usually. But it's been in none of the books, and people ask me about it, and that's why I put it in the book. So I don't really call this an advanced trick, but it's a trick that wasn't in any of the books. Okay, so what do I mean by number of diagonals? Well, let's say I had a pentagon, yeah? So how many diagonals can I draw from this corner, right? Well, I can draw 1, 2, right? 2 of them. And if you look at that, it was 5 sides, but I can only draw 2. And the way you do that is you did 5 minus 3. Yeah? So that's the first formula. The number of diagonals from one corner is n minus 3. Now, if you've worked with me for a while, I taught you a way how I know it's n minus 3. Can anyone explain why it's n minus 3? People that I've talked with before probably know, but anyone? Why would it be n minus 3 from a corner?
It would be n minus 3 because there are 3 sides that you can't get to, 3 corners that you can't get
Right.
to.
Yeah. You can't get to this one because you're there, right? And you can't get to the 2 that you're already touching. Is that what you're basically saying?
Yeah.
Yeah, exactly. That's why it's minus 3. Okay? So the number of diagonals from any vertice, from any corner, is n minus 3. That's the first formula. Okay? And then the total number of diagonals, okay, is going to be, now I'll explain this for a second. You would think the total number of diagonals would be n minus 3 times n, because every corner could do n minus 3. But if you do that, you realize your answer is twice as big as you thought it should be. And the reason that it's twice as big as you thought it to be is the reason you have to divide by 2 is one time you're going to construct this diagonal, but later on when you do the other diagonal, you're going to do the same diagonal. And so you're double counting every diagonal, right? Every diagonal is being counted twice, okay? And since every diagonal is being counted twice, you'd have to divide by 2 because you double counted, okay? So that's the total number of vertices. So there's our 2 formulas. One vertice, n minus 3, total vertices, or total diagonals, n times n minus 3 over 2. Okay? So if I was to do this, the number of diagonals from one vertice, that's just n minus 3. I have to know my agons, right? Hepta is 7, so 7 minus 3 is 4 diagonals. If they say total number of distinct diagonals, that's total. That's the same thing as saying total. Okay? So that would be n minus 3 times n and divide by 2. What did I say? Why do you divide by 2, guys?
Because
you're double counting.
Double counting. I'm double counting every vertice, so I got to get rid of half of them. Okay? So I'm going to do 5 minus 3 times 5 over 2. 5 minus 3 is 2. 2 divided by 2 is 1 times 5 is 5. So n minus 3 times n over 2. All right. I'm not even going to do this problem with